Everyone, let's see today's LeetCode problem number 121. Best time to buy and sell stock. The problem states in this way, like we have given an array prices, okay, where prices of I is the price of the given stock on the right day. You want to maximize your profit by choosing a single day. Okay, it's nothing. Okay, if you see the example right, what does the problem say? In the prices of the particular array of the ith element indicates you are buying the stock, and you have to sell the stock in the I plus one. Okay, not in the I minus one, I plus one, and you have to get the maximum profit. So for example, if you see this example, like price is 715364, like buy on the day two for the price one, buy at the minimum price and sell at the maximum profit, maximum price. Okay, so minimum price is one and the maximum price is six over here. So if you calculate, which gives six minus one, which is five. So maximum profit is five. Let's say, let's say an example here. We have an array which gives us 7, 1, 3, 5, 6, and 2. Right. If we buy on ith day, which is on the day one, and sell it on day 5, which is 6, which gives us 6 minus 1 is equals to 5, right? Which is the maximum profit. To solve this problem, we have two solutions. One is brute force, and the other one is optimal. So when it comes to brute force, it's an easy solution, right? What you'll be thinking, you will take this element and while iterating this element with the first loop, and you'll use the second loop to calculate the selling price, right? So it's the same thing. Just run for loop for I to n, then second loop for j, where j will be I plus 1 to n, right? What you'll be doing, if array of I is no, no, not in this way. If array of j minus array of I is greater than the maximum profit, just check whether it's the maximum profit. If it is maximum, then update maximum is equals to array of j minus array of I. So in this way, if you calculate the time complexity, right, this takes big of n, this takes big of n. If you calculate total time complexity, which results us at big of n square. So this is a huge time complexity. We have an optimal solution as well. Let's look into the optimal solution. Let's say we have array 7, 1, 2, 5, 6, let's say 3. Right. What we'll be doing, we'll take the minimum price first. Let's say minimum price is a minus infinity, negative number, right? Minus infinity. And let's say for tracking the maximum count, let's say maximum E, we have 0. Now, for I in array, right? The first condition will be, I'll be checking whether the current element is the minimum price to buy. So, whether minimum price is is greater than the current element. If it is greater than current element, then we'll not buy. I mean, yeah, then it will not will buy it as the minimum price. So we'll update minimum price as I. Right. Now check. If it is not matching this condition, then we have to check whether the maximum profit is greater than current element minus minimum price. If it is giving the maximum profit, then I have to update the max is equals to I minus minimum price. Right. Then after iterating the loop, I'll just return the max, return the maximum element. If you say we are using only single loop, which is big of n, which reduces from n squared to n, and the time complexity we have, I mean space complexity we have big of n, and time complexity we have big of n. Right. If you trace the code, let's say the minimum price is minus infinity now, and the maximum element is 0 here. Right. For I in array, what is I? I is 7 here. Check whether minimum price. What is minimum price? Minimum price is minus infinity. Is minus infinity greater than 7? No, absolutely no. Because negative number is always lesser than the positive number, which is 7. So we'll be updating minimum price here. Let's MP is an minimum price. MP is equals to, which will be 7 here. It will not execute the else if condition. It will move forward at 1. Now check. The minimum price is 7. Is 7 greater than 1? Absolutely yes. 7 is greater than 1. So we'll update the minimum price from 7 to 1. Now check. What is the next number, which is 2? Is 2 is 2 greater than sorry, yeah, minimum price is 1. Is 1 greater than 2? No, it's not greater than 2. It will execute the else if condition. What is the else if condition? Else if condition maximum. Is maximum element 0? Which is 0. Is 0, sorry, this will be less than. Is 0 less than, what is the current element? Current element we have 2. And what is the minimum price? Right now we have minimum price is 1. Is 2, is 0 less than 1? Yes, absolutely 0 is less than 1. So the maximum profit will be currently a 1. Just imagine we are buying stock at 1, minimum price is 1, and selling at 2, which is 2 minus 1. Current maximum profit we have 1. We'll be moving further ahead, okay, which is a 5. What like minimum price is 1. Is 1 is greater than 5? No, it will go to the else if condition. What is the maximum profit? Which is 0. Is 0 less than 5 minus 1? If you see here, current element is 5 and minimum price is 1. 5 minus 1, which gives us 4. Yes, 4 is the maximum profit. So I'll be updating 4 here. So current maximum profit we have, like if we imagine we are buying the stock at 1 and selling at 5, maximum profit is 4. Similarly, if we iterate to 6 here, we'll be having the same thing. 6 minus 1, we'll be updating the maximum profit. Similarly, it will go to 3, maximum profit remains same. So we'll be returning the maximum profit here. Right. Let's look into the lead code problem here. Yeah. Yeah, let's look into the lead code, and I'll just add a base condition here. If not, if prices of the array is empty, then I'll return 0 here, and minimum price is equals to, like, I'll just keep the maximum number. Sorry, while explanation I just made a mistake over here. So minimum price will be this one, plus infinity, right? So which is the maximum, so I have to assign minimum over here, infinity. And for the maximum I'll just give m is equals to 0 for I in prices, right? For I in prices, yeah, prices. I'll just check whether I is less than the minimum price. If it is less than minimum price, then minimum price will be I. In currently, just imagine minimum price is like a positive integer, which is a too large number over here. So what we'll be doing, the current element, let's imagine the first element is 7. Okay, whether 7 is less than, is 7 less than the greatest positive number? Yes, it is less than. So minimum price will be the 7 right now. So that's what we are assigning over here. Else it is not there. Then what we'll be doing, we'll be checking whether the maximum element is less than the current element minus minimum price. If it is the case, then I'll be updating the maximum profit over here. M is equals to I minus NP over here. I'll just return M. Let's check. Good. If you see the runtime, it's 87.04% bits among the other lead coders. If you analyze the time complexity over here, which is big of n.